All right, let's do this one. Find the area of the region bounded by y equals x cubed, y equals x plus 6, and the x-axis. All right, so right now I'm looking at this and I'm like, okay, let's graph these and let's see what's even going on here. This looks like it's just going to be a regular old region of the curve, right? Makes sense. So I have y is equal to x plus 6. 1, 2, 3, 4, 6, 7, 8, 9, 10. 3, 4, 5, 6, just to make plenty. 5, 6, just to make plenty. And so I'm starting up here at positive 6. 1, 2, 3, 4, 5, 6. Right? And then I have y is equal to x plus 6. So my slope is 1. I'm going to make plenty here of points just to make sure that I'm covered. So here is my graph. Y is equal to x plus 6. I'm just going to write it over here. Y is equal to x plus 6. All right, so there's that one. Then I have this cube. So I know I'm at 0, 0, and then 1, 1, because it's cubic, right? If I plug in a 1, pardon me, if I plug in a negative 1, I'm going negative 1. If I plug in a positive 1, I'm going positive 1. 2, what's 2 cubed? 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, look at there. As soon as it hits off on that, I'm not going to go any farther. And I know this is also bounded by the x-axis from there. So I know I don't have to go any farther. So I should have said that up front. So I know because this says bounded by the x-axis, I knew I wasn't going to have to go down any farther because I was stuck here regardless of what was happening. Okay, so let's look at this. Here is my region. It's bound by the x-axis and these functions. Color that in. I always like to see my region because then I'm like, okay, what am I looking at here in terms of my region of where I'm looking at this? We could solve this 2 different ways whenever we're looking at this. You could take this graph and you could split it right here, right? Because this function right here goes up. This function right here goes up. But you could split the integration into 2 separate things. Oops, I forgot to write what this is. Or, look at how much nicer this is going to be. Because my graph is already set to function to function. Function to function, function to function. Every single place on this shaded area. This is always my bottom no matter what. This is always my top no matter what. I'm already set up that way. However, if I am going around this axis, the y-axis, this is an 8, obviously down to 0. That's a 0. If I'm going around that y-axis, that means my variable has to be in terms of y. So I solve for x. X is equal to y minus 6. X is equal to the cube root of y, or y to the 1/3, right? Either one of those. And I know my interval here is going from 0 to 8. That's the other reason why I like this, because 0 is one of my bounds. That makes my life so much nicer, right? That is so nice when we have that. So I'm going from 0 to 8 for my right minus my left, right? The biggest one, y to the 1/3, minus y minus 6 dy. Super easy. Distribute that negative sign. So I'm going from 0 to 8, y to the 1/3 minus y plus 6. And now you just integrate. You add, same thing, but when you add a fraction, right, it's plus 3 over 3. So I have y to the 4/3, and I'll bring that 3/4 in front, minus that 1/2 y squared plus 6y, from 0 to 8. You see that? And then you just plug it in. I'm going to scoot this up a little bit. So I've got 3/4, and I've got 8 to the 4/3 minus 1/2, 8 squared plus 6 times 8, and I'm just going to say minus 0 because that's a y. If you plug a 0 into all of these y's, you'll get 0. So I'm okay with you just writing that. Okay, now clean it up. I know the cube root of 8 is 2, so 2 to the 4th. So 2 to the 4th is what? 16? Minus 1/2, and 64 divided by 2 is 32, right? This is 64 divided by 2 is 32, plus 48, and then minus 0. Then you can reduce this. 4 goes into 16 4 times. So we're even like rolling this here, right? 12 minus, and if I take 32, negative 32 and 48, would actually end up being a plus. Oops, wasn't right in there for a second. 16. So I end up with 28 total. Not too shabby, right? All right, 28, nice and easy. You could also, just because I want to make sure you know, when you solve these problems, as long as you are mathematically correct, then I'll go for that. But you need to be efficient. The purpose of calculus, especially Calc 1, is developing your calculus skills. So we're developing those skills, develop into efficiency. So you could go about the x-axis here, and I could go from, what is this? 1, 2, 3, 4, 5, 6. This is a negative 6. I could go from negative 6 to 0 of my y-axis here, which is 0 minus, wait, top minus bottom. Sorry. X plus 6 minus 0. Because that's top, I'm going this other way. X plus 6 minus 0 dx, right? Plus, and then I'm going from 0 to 2, because that going to 2, 0 to 2 of my top, again, here is x plus 6 minus the bottom, which is x cubed dx. And then I'm not going to do this, solve this, to get 28, just so you know. You can solve that, and you're going to get 28 out of it. Because it's still the exact same area. The area is still the area. Whether you add the two small ones together or whether you add that whole piece up at one time, you're still going to get 28. Be efficient with your math, especially when it's nice and easy and you can pull it off like that. All right? Cool. Go practice these. Go rock the socks off this stuff.